Okay, notes 2.1, rates of change in the tangent line. So in these notes, we go back and discuss tangent line and secant line. And remember, these are the slopes of the line that either intersect 1 point or 2 points of the function. Okay. The slope of the tangent line is the instantaneous rate of change, or in other words, the derivative. We say that the point of tangent C is a comma f of a. I want you to think of this as x comma y. And that the slope at the point of tangent C is denoted by f prime of a. So this is the slope, m. Okay. Average rate of change. So average rate of change is when we think of the secant line. And remember, that is f of b minus f of a over b minus a. Think the slope formula, y2 minus y1 over x2 minus x1. So for this problem, it's saying using the function, find the rate of change over the interval 1 and 3. So that's the same as saying f of 3 minus f of 1 over 3 minus 1. So we're going to plug in 3 into this function, and then we're going to plug in 1 into this function. When you simplify all this, we get 10. Another way we could think of average rate of change is by using the definition of the derivative, where we do f of a plus h minus f of a all over h. And then when you see this again, usually it is the limit as h approaches 0. Okay, when you see this, it's just that same concept of f of b minus f of a over b minus a. Okay, and this is what I was talking about above, where that slope is the limit as h approaches 0. Okay, so in this part, this is kind of breaking down the formula that they give us, and we're practicing plugging in a and then plugging in a plus h. So for example, here we plugged in a. So anywhere we saw an x, we substituted an a. And then for f of a plus h, anywhere we saw an x, we plugged in a plus h. And that's what we did for each of these problems here. Okay. For this one, we're actually taking the function and we're using that f of a plus h minus f of a over h and plugging in a point 3 comma 9, which means we're plugging in a and a plus h into the function x squared. And when we do that, we get this. Okay, we FOIL out this part, and that's how we got this part. We simplify, combine like terms. Eventually, the h's are going to cancel out, and we are left with 2a, which is the slope of the curve at the point 3 comma 9. And we know our point 3 comma 9 is a f of a. So that means a is equal to 3, so our slope is going to be 6. Okay. Same concept when we're talking about tangent lines. When we're talking about tangent lines, once we're given the slope and the point, we use that formula y minus y1 is equal to m x minus x1 and plug in all our values. What's nice is that we do not need to simplify further than this. Once we plug in all our numbers, this is good enough. Okay, now let's talk about if our slope is undefined. Okay, if our slope is undefined, that means we have a vertical tangent line. Okay, notice that we know this happens if the limit of that definition of the derivative approaches one of the infinities. Okay. So that was the tangent line. Now we talk about the normal line. So the only difference between the normal line and the tangent line is that the normal line is perpendicular, or in other words, the opposite reciprocal, change the sign, flip the fraction, of the slope of the tangent line. So in this example here, we are given a function. We have to use that formula, so definition of a derivative, in order to find our slope. Once we find our slope, we plug in the value they give us, okay? That is going to be our slope of our tangent line. From there, we're able to write our tangent line equation and our normal line equation because the reciprocal, or the opposite reciprocal of negative 1/4 is just 4. Notice nothing else changed. Okay, just some more examples that we did in class. And that concludes lesson 1.